Hello and welcome to lesson number 4 in Unit 0 of our grade 10 academic math class. This is solving literal equations. So this is a bit of an adjustment from the lesson that we just did, which was solving polynomial equations. Polynomial equations have, generally speaking, just one variable that you're trying to isolate, and you're trying to find a value for that variable that makes the left side of the equation equal to the right side. When we talk about solving literal equations, generally speaking, while there can be numbers, there tends to be a lot more variables in the mix, and that can be confusing for people. The thing to remember is that a variable, when you're performing mathematical operations on it, functions exactly like a number, in that when you have a letter, you can add it, subtract it, multiply it, divide it, square root it, or it can be included in brackets. So all the rules of BEDMAS apply to letters as well as numbers. So let's start working through some of these literal equations. The first one here I have already done for us, and we have solve d equals r times t, and we're trying to solve for r. So essentially what that's asking you to do is to isolate r all by itself and see what it's equal to. The way that we do that is by determining what exactly is happening to r. So if we look at this original equation, I'll just sort of highlight it here what I'm talking about. Well, there's r, and what is currently happening to it is being multiplied by t. And how do we undo that? Well, we need to divide by t to undo it. We have to do it to both sides of the equation in order to keep it equal, because an equal sign is a promise that you're going to keep the left side of the equation equal to the right side by doing identical things to both sides as you manipulate it. So if we divide both sides by t, what you find is you've isolated r, and on the other side of the equation you now have a value that is equal to it, in this case d divided by t, and that's our answer. Really, the thing to remember when solving literal equations is that you're going to perform BEDMAS backwards, exactly the same way you did when you were solving polynomial equations. So getting the list of things that are happening to the variable, at that point you can start to undo them following BEDMAS backwards. So undo adding and subtracting before you undo multiplying and dividing, before you undo any exponent stuff, and before you work on any brackets. So let's look at another example. Here we have P equals 2L plus 2W, and we're trying to solve for W. So what I've done is I've rewritten this and found my variable. So there's my variable, W, and what's currently happening to W is it's being multiplied by 2. I also, in this rewrite step, did the first step, which is to move 2L to the other side of the equation. So I transposed it by doing the opposite of what's happening to it. So at that moment it is a plus 2L. I undo that by subtracting 2L from both sides. Then I go on, now that the addition subtraction is done, I move on to dividing by 2, which gives me P minus 2L divided by 2. Now I do want to point out that there is a second way that this answer might be written, and it might be written as W equals P over 2 minus L. Now the reason I mention this is not because one is righter than the other, it's just that when you're completing your homework, some of the answers on the answer sheet might have a slightly different appearance than the answer you arrived at. But I assure you, both of these answers are equally correct, it's just they're written in slightly different ways. In the second one, the one that I've just written down, the authors, I guess, of the worksheet have gone on to divide both parts of the numerator by 2. In the case of minus 2L, it's actually become minus 2L divided by 2, which gives you minus 1L. So that explains, and then obviously P is left being divided by 2. So slightly different appearance, but the same correct answer. So don't fret if your answers don't line up exactly. Maybe try to recall that sometimes, especially if you have something in the denominator that can be divided out evenly from one of the components of the numerator, they might go ahead and do that. But like I said, if they're both right on a test, I would mark both of these answers as correct. Okay, let's go do one together. Here we have Q equals C plus D divided by 2 for D. So here is our variable, D. And what is happening to D? Well, D is being, let's change up my color scheme here. So D is having C added to it, and it is also being divided by 2. Oops, I've already used orange. Being divided by 2. Now, I just finished telling you that we need to do this as if we're working through BEDMAS backwards, but I want to remind you that when you have a fraction on one side of the equation that has a multi-part numerator, there are implicit brackets around the numerator. So these implicit brackets exist here, which means that if we're considering moving through BEDMAS backwards, although I just told you that we should subtract C first, because it's contained inside the brackets that comprise the numerator, that's actually a b for brackets in BEDMAS. So we need to undo the divide by 2 first. And how do we undo that? We are going to multiply both sides by 2 in order to keep this equal. So my next line then is going to read 2 times q, which is 2q, equals c plus d. Now what you'll notice is that now that we've multiplied by 2, we've essentially removed the fractionness from the right side, which means that those implicit brackets around the numerator have now vanished. So what we have now is 2q equals c plus d, and we can go on to isolate d, which is the one we're looking for. And how do we do that? Well, d as having c added to it, so how do we undo add c? We're going to subtract c from both sides, again, to keep it equal, which means that our final answer is 2q minus c equals d, and that is our final answer. So therefore, d equals 2q minus c. There we go. Some people ask about this. One of the properties of equalities, so basically an equality or an equation, something that has an equal sign in it, is that you can rewrite the left side in the place of the right side and vice versa. So I tend to like writing my isolated variables on the left in my final answer. So I can just rewrite the d on the left side and rewrite 2q minus c on the right side, and there's no problem with that. It's just something that you can do with equalities because obviously the left side is equal to the right side, so you can rewrite them identically. Hopefully that makes sense. Some students just panic when they're like, do I have to subtract d from both sides and then subtract 2q and add c? You do not. You can just rewrite the left side and the right side on the opposite sides of the equal sign with no harm, no foul. Okay, let's have a look at one final example. So we have solve v equals 3k over t for t. All right, so there's our variable t. It shows up here in the denominator. So what's happening to it? Well, at the moment, it is being multiplied by 3k. Now, again, part of the examples that we pick in our note, in our lesson, are because there's maybe something about it that is particular, and I can show you a way to work through it more easily. In this case, what I'm going to show you is that when the variable you're trying to isolate is in the denominator, it's actually in kind of a tricky position, because if from here, based on what I said before, if I've got t and it's being multiplied by 3k, I would undo that by dividing both sides by 3k. But then all of a sudden I have v over 3k equals 1 over t. That's not t. 1 over t is not t. So in order to get the variable out of the denominator, what I'm going to suggest, if there are two fractions, or two values, terms I guess, one on each side of the equal sign, what you can do is you can actually set this up to cross multiply, which is pretty cool. So I can do the numerator of the first side times the denominator of the second, and denominator of the first side multiplied by the numerator on the second. So let's go through that cross multiplication. That cross multiplication gives me v times t equals 3k times 1, so just 3k. So what you'll notice in this step is now I've effectively taken the t value and gotten it out of the denominator of the fraction. So at this point, I can reevaluate what's going on. There's my t value. What's happening to it? It's being multiplied by v. How do we undo that? We're going to divide both sides by v, which gives me t equal to 3k divided by v. And that is our final answer, in that we've isolated t. Hopefully this is making sense. There are two more examples here on the page. It'll make the video a little bit longer, but I'm going to try to push through them here. So here we have solve a equals pi r squared s divided by 360, and we're trying to solve for s. So let's look at what's happening to s. First, it is being multiplied by pi r squared. Again, if there's multiple things being multiplied by our variable that we're trying to isolate, we can kind of lump them together, because multiplied by pi, multiplied by r, that's all. We can kind of just keep it together. The other thing that's happening to it is that it is being divided by 360. Now both of those operations, multiplying and dividing, happen at the same step in BEDMAS, so it doesn't matter which one of them you do first. But again, in an opportunity like this, I would say maybe because we have a single term on the left side of the equation and a single term on the right, I would suggest maybe we do some cross multiplying again. So let's make that happen. There's our cross, and once we're done our cross multiplying, what we get is 360 times a equals pi r squared s. So now we have an opportunity to isolate our variable here. In one step, we are going to divide both sides by pi r squared. And that, fortunately enough, gives us our final answer. So 360a divided by pi r squared equals capital S. Now, I'm not going to bother to rewrite it this time. I'm just going to cheat a little bit to keep the video a bit shorter. As I said, normally I would probably rewrite this with S on the left side of the equation, but no need. Okay, hopefully this is making sense. Let's do one final example. So we have capital A equals a plus b in brackets times h all over 2. So we are trying to isolate little a, which is awesome. What's happening to it? Well, it is being added to b, it is being multiplied by h, and it is being divided by 2. So lots of stuff to keep straight here. And I do want to remind you that that plus b, although I have said that we should be following BEDMAS backwards, because it's contained in brackets, not even implicitly this time, it's just in brackets, that's actually the last thing that we're going to do. So we need to undo multiply by h and divide by 2. Again, we're given an opportunity here because we have a single term on both the left and right sides of our equation. We can, as before, cross multiply. So let's try that now. When we cross multiply, we get 2 times a equals a plus b times h. So we're trying to isolate a. We've now gotten rid of the fractionness of it. We've essentially taken care of the dividing by 2 by multiplying both sides by 2, essentially. And now we are going to undo multiply by h, which we do by dividing both sides by h. So we have 2a over h equals a plus b. And as I said in a previous example, now that a and b are not a numerator in a fraction or a ratio, we can actually let go of those brackets. And now in this, to isolate a, we are going to undo plus b. How do we do that? We are going to subtract b, but we must do it from both sides. So once we get that done, we have 2a over h minus b equals a. So that is our final answer. This time I will do a rewrite. So a, therefore, a equals 2a over h minus b. And that is our final answer. Now I want to point out, just at the very tail end of this video here, that one of the things that students do to sometimes make, or that is sometimes an error, is that they will continue this. Let me change up my color scheme here so you can see it. Sometimes when rewriting, they will intentionally sort of continue this line here to create a fraction that has 2a minus b as an entire numerator. That's not the case. That's incorrect. And the reason it's incorrect is because we divided by h before we subtracted b from both sides. So not right, gonna get rid of that. It has to be 2a over h minus b, and not 2a minus b as a numerator over h. Hopefully that makes sense. That is our lesson. There is a worksheet on the following page to go through for homework. As always, if you have any questions, please feel free to email me or contact me directly. We'll get you through any troubles that you're having. Otherwise, good luck with the homework, and we'll see you in the next lesson.